Hey everybody, it's Miss Berry. In this video, we're going to be going over section 1.7. So I'm going to go ahead and flip the screen around and we'll get started. All right, let's go to the beginning. Okay, section 1.7 is called Linear Inequalities in One Variable. So we're going to be looking at a few different types of inequalities today. All right, so just to remind you of what our inequality symbols mean. The inequalities we're going to be discussing today, we're going to have some less than problems. So this symbol means less than. We're going to have some greater than problems. Then we'll have some less than or equal to. And some greater than or equal to. Now, technically, the not equal to symbol, that's also a type of inequality, but we're not going to be looking at that type of inequality today. So just the ones I have over on the left here. All right, so let's go ahead and get started. It says here, solve the linear inequality, use interval notation to describe the solution set, and then graph the solution set. All right, so here we have 5 minus 2 times x minus 3 is less than or equal to negative, and then in parentheses, 1 minus x. So you may have to pause the video, take a second, write this down. I'm going to go ahead and get started. So the first thing that we're going to need to do here is go ahead and multiply through by negative 2 on the left-hand side. And then we can go ahead and distribute that negative on the right-hand side. All right, so we're just simplifying, and then we will combine like terms. So that's going to be negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6, less than or equal to negative 1 plus x plus x. All right, so now what we're going to do is get all of the x's, or whatever your variable is, on the left-hand side. So get the variable on the LHS, which stands for left-hand side. Left-hand side. All right, so let's go ahead and combine some like terms and start moving stuff. 5 plus 6 is 11. All right, so let's move this x over here to the left-hand side. It's going to cancel over there. So that's 11 minus 3x. Negative 2 minus, this is like minus 1x. So negative 2x minus 1x, that gives you negative 3x. Less than or equal to negative 1. All right, go ahead and move the number to the other side. Whoa, minus 11. Sorry about that. I was already subtracting it in my head, I guess. All right, so minus 11, so it cancels out over here. That's negative 3x less than or equal to negative 1 minus 11 is negative 12. All right, now we're trying to get x by itself. So we're going to divide both sides by negative 3. All right, but one important thing to know about inequalities is anytime you multiply or divide by negative, you must flip the inequality. Okay. All right, so we got to flip this inequality right here. So this is going to become just x on the left-hand side because that's going to cancel. This is now going to be greater than or equal to instead of less than or equal to. Negative 2 divided by negative 12 divided by negative 3 is positive 4. All right, so it says next we should use interval notation to describe the solution set. The way that I like to do this is to actually just go ahead and draw the graph. So technically we're let me see, we're kind of skipping this middle part and we'll go back to it. So I think drawing the graph really helps you to write interval notation if that's not something you're comfortable or familiar with. Right, so anytime it's asking you to graph an inequality, it means on a number line. So here I've drawn my number line. I'm going to mark the relevant number. Here it's 4. All right, and then some things to remember. Anytime you have a little equal to under here, so whether it's greater than or equal to like it is here or less than or equal to, then that's going to be represented by a bracket on the number line. All right, and so it says all of the x's that are greater than or equal to 4. All right, so I'm going to draw a little bracket. I'm going to open it towards the side that's greater than 4. So all these numbers out here would be bigger than 4. And then I'm just going to shade the side that's bigger than 4. So all these numbers out here are bigger than 4. Whoa, went too far. Let me try that again. All right, so there's my solution. All the numbers bigger than 4. So that's my little graph. And now I can go ahead and convert that to interval notation. It's pretty easy now because you can see I have a bracket that opens this way at 4. And then I'm shading all the way out here to positive infinity. All right, so 4 to positive infinity. Anytime you have an infinity, whether it's positive or negative infinity, you always do a parentheses. All right, so this was kind of a 3-part question. It wanted you to solve the inequality. That was this part up here. And then interval notation for the solution set, that's at the bottom, and the graph is here in the middle. All right, so let me just write a little note here. Always use parentheses around positive infinity or negative infinity. All right, let's look at another problem. We're going to look at compound inequalities next. Compound inequalities are going to be inequalities where you have more than one inequality symbol. So there are 2 types of compound inequalities. We have what are called conjunctions, which is what we're going to look at in this first example. And then we're also, another type of inequality, a compound inequality, is called a disjunction. So we have conjunctions and disjunctions. We'll do one of each. Same or similar directions here. It says solve the compound inequality. Use interval notation to describe the solution set. Then graph the solution set. Okay, so we have 10 over 6 is less than y plus 2 over 3 is less than 23 over 6. All right, so your goal here, again, this is called a conjunction. So this is a conjunction. A conjunction is where you just have 2 inequalities and they're kind of like smashed together. So anytime you're working with a conjunction, your goal here is to get the variable in the middle by itself. All right, so you're trying to get y by itself here. So the first thing that's in my way is this fraction. So I'm just going to multiply by the denominator, multiply everything by the denominator. All right, so in the middle here, that's going to cancel out. 3 and 3 cancels out. Let's see, 3 times 10 would be 30. 30 divided by 6 is 5. Is less than y plus 2. Is less than, let's see, that's going to be 23 times 3 is 69 over 6. And that's going to reduce to 23 over 2. but you can do that in your calculator if you want to. All right, so last thing we got to do is trying to get y by itself again here. So I'm just going to subtract 2. Notice that I'm subtracting 2 from every side, from the middle, from the left, and from the right. And same thing with multiplying by 3. I multiplied 3 to the middle, multiplied 3 to the left, and multiplied 3 to the right. All right, so let's simplify here. 5 minus 2 is 3. It's less than y. Less than, let's see, that's going to be, I'm just kind of doing this in my head. I do have a calculator right here, but let me just show you how I would do this in my head. Or I would say, okay, well, I could write 2 as 4 divided by 2. And then I can easily subtract this in my head. Subtract the top, bottom stays the same. 23 minus 4 is 19. Denominator stays the same, so that's over 2. All right, so now I'm done solving. I've got y by itself, so I'm going to graph it on a number line, and then I'll write interval notation. And interval notation, I probably should have mentioned this at the beginning of the video, but interval notation just refers to parentheses and brackets. All right, so marking 3 on the left. I know that 19 over 2 is definitely bigger than 3, because 2 goes into 19 like what, 8 times? No, more than that, right? Yeah, 9 times, because 2 times 9 is 18. So it's definitely bigger than 3. All right, so marking my 2 relevant numbers. And with conjunctions, it's pretty simple. You always shade in the middle. We got to write our either parentheses or brackets here. You can see there's no equal to sign under my inequality here, so I'm going to do 2 parentheses. And I'm just going to open them towards the middle. So let me try that again. So if I can get it on the line. Parentheses, parentheses, and then just shade in the middle. Okay. All right, and then last thing we got to do is just write interval notation. Again, super simple. It's kind of done for you here in this number line. So you're starting with 3, open parentheses, all the way to 19 over 2 with the closed parentheses. And that's it. This is interval notation. All right. So let me just show you what a disjunction would look like. Actually, let me do a blank page, because otherwise it's going to get all cramped in there. All right, so here's an example of a disjunction. I'm just making this one up. Let's say 3x minus 2 is greater than 0, or 5x plus 7 is greater than 0. Actually, let's make that a different number. Let's make it 9 over here. Whoa. X plus 7 is greater than 9. Okay. This may come out with weird numbers, but it'll be okay. Disjunctions and conjunctions, super easy to tell apart, because disjunctions will always have this word or in them. And disjunctions are pretty easy to solve. You just solve them both separately. All right, so solve them one at a time. We'll start with this one on the left. Go ahead and move that 2 over, trying to get x by itself. And then divide by 3. So x is greater than 2/3. And I think I messed up here. I originally had that should have been a less than, so fix that. Sorry for the sloppy handwriting. See, I can probably make this a little bit neater. That's supposed to be a greater than. All right, now go over here and solve this one. Subtract 7. So 5x is less than 2. Divide by 5. So you have x is less than 2 over 5. Boy. All right, so now let's draw our little number line. All right, so you have to figure out which one's bigger, which one's smaller. 2/3 is definitely the bigger out of these two. If it helps you, you could, like, convert them both to decimal form. So let's see, 2/3 as a decimal. What's that, 0.66? Yeah, 0.6666 repeating. So about 0.67. 2/5 as a decimal is 0.4. So 0.6 is bigger than 0.4. So go ahead and mark your numbers. We said 2/3 was bigger, so put that on the right. 2/5 is going to go on the left because it's smaller. All right, and then neither one of these have an equal to on them, so that tells us that they're going to be parentheses. That's how we're going to represent them on the number line. And with disjunctions, you're going to shade on the ends of the number line. You remember with conjunctions, we shade in the middle. Disjunctions, you shade on the outside. All right, so we're going to draw our little parentheses facing the shaded area, which is going to be on the outsides, and then shade over here on the outside. All right, so this says has to be greater than 2/3. That would be on the right-hand side of 2/3, or it has to be less than 2/5, which would be on the left-hand side of 2/5. So this is probably the hardest one to write in interval notation. But you're just going to, read it off left to right. So start on the left, move towards the right. Out here on the left is negative infinity. So we're going to start at negative infinity. We know we always put a parentheses around negative infinity. And then a comma. It's shaded all the way to 2/5 with a parenthesis. So 2/5, close parentheses. Then we have this little gap here. Anytime you have a little gap like this, it's going to be represented by this symbol. It looks like a U, and that stands for union. And the union symbol is just a symbol that we use to join up two sets. All right, so then we open back up at 2/3, and then it's shaded all the way out here to positive infinity. Close parentheses. So that's it. Okay, we're going to do another one of those before the end of class. So if you feel like you might need extra practice on that one, that's fine. All right, so we're going to look at, this is, I think, the last topic we're going to look at. Let me see. Yep, we're going to look at this, and then we have a word problem at the end. So make sure you pause the video and take a second and write this rule down. It says, this is how you solve absolute value inequalities. So if you have the absolute value of x is less than a, then that implies, or that is the same as, or is equivalent to, that's what this symbol here means. It means this is the same as, it is equivalent to. So this says the absolute value of x is less than a is equivalent to negative a less than x less than a. So you can see that's a conjunction on the top there. And then at the bottom we have absolute value of x is greater than a is equivalent to x is less than negative a or x is greater than a. So again, this is a disjunction. All right, so when do you use these rules? You're going to use this top rule for any problem that has a less than or a less than or equal to. If it has a less than or equal to, you just write little equal to's on all of the inequalities. And then down here, you're going to use this second rule for any problems that have a greater than. And then similarly, if they have a greater than or equal to, you just add the little equal to's on all of your inequalities. All right, so similar rules apply for the case where you have either a less than or equal to or a greater than or equal to. Okay. I'm going to copy this and then we can paste it onto the next slide. All right, so here we go. Just going to put this over here. Make it small. Put it over here. Okay. All right, so directions here say solve the absolute value inequality, use interval notation to describe the solution set, then graph the solution set. All right, so we have 5 times the absolute value of w plus 5 is less than 10. All right, so all of these rules here, you can see top and bottom, they require you to have the absolute value by itself. So we need to move this 5 over before we do anything. Right now we're multiplying by 5, so let's divide both sides by 5 to get rid of it. So we have absolute value of w plus 5 is less than 10 divided by 5 is 2. All right, now let's determine which rule we should use. This is a less than problem, so we're going to use the top rule. Here, x is being replaced by w plus 5. So x here gets replaced by w plus 5, and a gets replaced by 2. Okay, so these a's here are going to become 2's. All right, so following this rule, and you can kind of write it underneath if you want to, like this. You could say absolute value of x is less than a is equivalent to, that's my very poorly drawn double-sided arrow, negative a less than x less than a. So you can kind of match up, x matches with w plus 5, a matches with 2, and then just plug it in. All right, so that becomes negative 2 less than w plus 5 less than 2. Right now, this is just a simple conjunction, and we can go ahead and, just get w by itself. We're going to subtract 5 from every side. Cancel that out. So that becomes negative 2 minus 5 is negative 7. Less than w is less than, that's going to be negative 3. All right, so go ahead and graph it, and then we'll write interval notation. All right, negative 7 is the smaller number, so it goes on the left. Negative 3 is the bigger number, it goes on the right. Again, with conjunctions, you always shade in the middle. So let's go ahead and draw our little, we're doing parentheses or brackets here. We don't have any equal to, so we know we're going to do parentheses. And then conjunctions, always shade in the middle. Okay, now it's super easy to write interval notation for this. You're going to start at negative 7 with a parentheses, end at negative 3 with a parentheses. That's it. All right, we have, this is our last absolute value inequality problem. Let me move that over here again, so we'll just have it on the page with us. We don't have to refer back. All right, so here our problem is absolute value of 2y minus 2 is greater than or equal to y plus 8. Okay. All right, so we have our inequality on the left by itself. So we know that we can go ahead and apply our rule. So basically what I mean by that is there's no coefficient here in front of the absolute value. So let's apply the rule. We know that we're going to use this rule down here because it's for greater than problems. Whoa, let me try that again. Since this is a greater than problem, we're going to use the second rule. And I don't know why it does that. Sometimes it makes my pen disappear so I can't see where I'm pointing. And we got to make sure and put the equal signs on there. Oh my goodness. It like makes it to where I can't see my cursor, so I don't know where I'm writing. Did it again. All right, so let's go ahead and write our rule up underneath here, and we'll match up with our formula. So we have absolute value of x is greater than or equal to a is equivalent to x is less than negative a, or x is greater than or equal to a. Oops, I missed my little equal to on here. Be careful, that's super easy to do. All right, so as you can see, let me escape out of this and come back and see if it'll make my cursor pop back up. Sorry, you guys. All right, maybe it'll work now. So as you can see, here, x is getting replaced by 2y minus 2. And then a, nope, still can't see my cursor. A is getting replaced by y plus 8. I don't know what happened, why it's all of a sudden messing up. All right, so replacing it in this formula here, we have 2y minus 2 is less than or equal to 2y minus 2. I don't know why I put a negative in front of that. Now they got me all messed up. All right, let's start over. X gets replaced by 2y minus 2. So 2y minus 2 is less than or equal to negative a, so that's going to be negative y plus 8, or x is greater than or equal to a, so that's 2y minus 2 is greater than or equal to positive a, which was again y plus 8. All right, so let's go over here to the left-hand side. This is a disjunction, as you can see. So we are going to solve these both separately. I'm going to start by distributing the negative over here. So I have 2y minus 2 less than or equal to negative y minus 8. I want to move my y's to the left-hand side, so I'm going to add y, so that's 3y minus 2 less than or equal to negative 8. Move the 2 over, so that's 3y less than or equal to negative 6. Divide both sides by 3. I'm trying to not stop so that I don't lose my place. So that's y, see like I did there. Y is less than or equal to negative 2. Over here, now I'm on the right-hand side over here. So I'm going to move my y to the left-hand side. So minus y. That's going to cancel. Then we have y minus 2 greater than or equal to 8. Add 2 to both sides. So we have y is greater than or equal to 10. All right, so now draw your number line. Mark your two relevant numbers, negative 2 and 10. Yeah, this thing is not wanting to get along with me today. Negative 2 and 10. All right, these have equal to's on them, right? So my inequalities have equal to, so I'm going to use brackets. And this is a disjunction, so I'm going to shade on the outside. All right, so I'm going to mark. No, I don't want me to use a different color. Use brackets. You're going to write your brackets open towards the outside. And then shade on the outsides. All right, now you can easily write interval notation. We know it's going to start out here at negative infinity. We know that negative infinity always has a parentheses. From negative infinity all the way to negative 2, close it with a bracket. Gap is represented by a union. Open back up with a bracket at 10. Shade all the way to positive infinity. Close with a parentheses. All right, last problem. Is this application problem. So it's just a word problem. It says, in a class in which the final course grade depends entirely on the average of 4 equally weighted 100-point tests, David has scored an 85, a 76, and a 92 on his first 3 tests. What range of scores on the 4th test will give David a B for the semester, which is an average between 80 and 89 inclusive? All right, so first of all, this word here, inclusive, is going to tell us that we should use like less than or equal to's and greater than or equal to. So that's what inclusive means. All right, so first let's write the formula for David's average. So David has 4 tests. He's already taken 3 of them. So we have an 85, a 76, and a 92. To get their average, we would just add up the 4 tests. We don't know the 4th test score, so we're going to represent it with an X. So you just add up the 4 test scores and divide by 4. So this is the formula for the average. So again, you take the first 3 test scores plus whatever they score on the last test, which we don't know. So we represent it with an X, and then divide by 4 because there's 4 tests. And we know that this average, we want it to be between 80 and 89. So we're going to write the average should be between 80 and 89. All right, so let's go ahead and add this stuff up. I'm going to start by just adding 85 plus 76 plus 92 is 253. All right, so we have 80 less than or equal to 253 plus x over 4 less than or equal to 89. That way we just combined our like terms. This is a conjunction, so we are going to try to get x by itself in the middle, and we're going to multiply every side by 4. That's going to get rid of that fraction. Multiply by 4 everywhere. That's going to cancel out in the middle. 80 times 4 is 320, less than or equal to 253 plus x, less than or equal to 89 times 4 is 356. All right, getting x by itself, so go ahead and subtract 253 from all sides. So cancels in the middle. 320 minus 253 is 67, less than or equal to x, less than or equal to 356 minus 253 is 103. Whoa. 103. So David must score between a 67 and a 103 to get a B for the semester. All right, so in order for David to get a B for the semester, which we said was between 80 and 89, he needs to score between a 67 and a 103 on the final test. All right, so that's everything for section 1.7, which again was about linear inequalities. If you have any questions, please let me know. Otherwise, I'll talk to you guys soon. Hope you have a good day.